Hi, everyone. Good afternoon to those on the East Coast, especially those in Virginia, and good morning again to Bill on the West Coast. We'll get started momentarily. We'll just give it about a minute or so, let other folks join, and everybody get situated, and then we'll kick off. All right, I think we can get started now. Hello and welcome to today's SolSmart virtual training. My name is Nick Kaza, and I'm a program manager focusing on energy and sustainability with the National League of Cities. Today is the third session in our three-part training series on best practices for solar PV permitting and inspection. Today we're going to focus on best practices for field inspectors. Sessions 1 and 2 focused on the simplified permitting process. The first session focused more on the structural side of things. Last week we finished simplified solar permitting focusing on the electrical side. And today we're going to kind of bring the entire permitting and inspection process to a close with some tips for field inspections. Before we get started with the presentation, I'd just like to review some webinar details. All attendees are muted and will be throughout the session. The training is being recorded and the recording will be available online. We'll figure out a website to host it at, potentially SolSmart's website, all three of them. Please submit questions to the organizer through the question feature in GoToWebinar. If that isn't working, you can email me at kaza@nlc.org. Take a quick look at the agenda, same as the last two sessions. I'll give a very quick intro on SolSmart. We'll hear from Carrie and Elizabeth about the Virginia SolSmart Initiative, and then we will turn it over to Bill for his presentation on best practices for field inspection. So once again, this training is brought to you by SolSmart, a national designation and technical assistance program for local governments funded by the U.S. Department of Energy. SolSmart aims to designate communities gold, silver, or bronze, and we have a team of technical assistance providers here to help communities in various categories to make their local government policy and processes solar friendly. With that, I will turn it over to Carrie and Elizabeth to speak briefly about the SolSmart in Virginia initiative.
Thank you, Nick. Good to be here and welcome everyone. Thank you for hopefully returning for your third training, or maybe you're participating as a standalone. Either way, we're glad to have you here. I'm the solar program manager at the Department of Mines, Minerals, and Energy based in Richmond, Virginia. And we're pleased to be working with SolSmart and UVA to offer no-cost technical assistance to localities to really help the development process around solar, in part to reach our state's clean energy goals by mid-century, as was set forth through Governor Northam's Executive Order 43 and put into law through the Virginia Clean Economy Act in the 2020 session. And we are happy to follow up with anyone after this. And we're also encouraging localities to submit a request to become SolSmart designated for your community. And if you go to the dmme.virginia.gov website, you'll find on our SolSmart page a form where you can request a consultation. We're working with localities across the state, in particular, looking for localities to join from the Middle Peninsula, the South Side region, and to continue to work from the earlier designation that the Southwest Virginia communities achieved last year. So with that, I will turn it over to Elizabeth Marshall.
Hello, everyone. Thanks again for joining us. Thank you, Carrie. So I'll tell you a little bit about myself. My name is Elizabeth Marshall. I'm the program coordinator for the Virginia Solar Initiative. The Virginia Solar Initiative is housed within the Weldon Cooper Center for Public Service at UVA. And so as such, our focus is to help support localities across Virginia as they're developing policies and procedures related to solar development, both at the utility scale and at the distributed scale. And so this partnership with DMME and SolSmart was a natural fit. It helps us leverage some of the resources and research capabilities that the University of Virginia brings with the excellence that the SolSmart program is known for, to deliver this no-cost technical assistance to potentially your locality. So I echo Carrie, if you're interested in joining up with us, to contact us. The email is on your screen, virginiasolsmart@virginia.edu, or to fill out a request a consultation form on the DMME's SolSmart website. Or if you have additional questions around policy or technical assistance that's beyond the scope of SolSmart, we're happy to help you, and we're there for you. So please contact me directly. Thank you so much. And Nick, now if you'd like to kick it off.
All right, thank you very much, Carrie and Elizabeth. And I will turn it over now to Bill Brooks so we can begin the field inspection presentation. Bill, how's the audio sound?
Sounds good. So how do I show my screen?
Just gave you the controls for presenter.
All right. Well, it's good to be back again. Thanks everybody for joining the third and last installment of this training. And I'm now finishing up week 1 of evacuation. So lots of fun to be had, living out of a 21-foot trailer, and which is plugged into the side of my son's house. I had installed a 50 amp plug on the house to charge electric vehicles, and that happens to be the same plug that's used to plug in RVs. And so I am parked next to that plug with my RV and plugged in there, and that's where I sleep with my wife, dog, and cat. So that's where we're at, but today we're going to be talking about field inspections. And so this will be a brief session. We'll definitely have some time at the end for discussion and questions, and discuss a lot of what's going on these days in the field inspection world, which is definitely taking on some new aspects that have not been there before, or not been there in any large measure before. But so let's just go through these materials, and if you have questions as we go, put them in the chat. Nick will be looking for questions in the chat. And also you'll have my contact information, and I get contact from inspectors all over the country on a pretty regular basis, asking specific questions about things as they come up in their inspections, to help them understand the process. And I enjoy helping people in the field in the process of inspecting systems and equipment. As again, I've been doing this for 32 years, been writing inspection procedures for at least 20 years. And so this particular set of guidelines, field inspection guidelines, came out of some work that I did with the state of California, and then we morphed it for SolSmart. And so first of all, when we're operating or doing an inspection, a field inspection, the first thing we usually start with is that the disconnects and the circuit breakers are turned off and in the open position. Now you see there's two switches in this picture, and they're both in the on position, or what we call the closed position for an electrical circuit, a closed circuit versus an open circuit. However, that being said, this system is operating, and so normally this is to show that you would normally have these switches off to start the inspection. All right, the next, one of the things we discussed when we were putting together these guidelines, and I've done many guidelines over the years, a lot of folks that were writing the guideline were wanting to put all kinds of information. They got like a 7-page list, and it was a nice list. When it comes to field inspections, the field inspector has between 10 and 20 minutes to perform a field inspection of a solar project like this, which is not a tremendous amount of time, because they have I've run into inspectors, especially in a fairly small geographical area, that might have 15 to 20 inspections in a day, and I just can't even fathom that. But there's some of the folks on this call that probably can, and actually do that on a regular basis. So inspections, there's not an enormous amount of time. The main thing that an inspection is for is to get a general overview of the project, make sure there are not any safety violations, and if there are things that are not according to code, making sure that those things get documented and resolved. But it doesn't mean that you're going to scrutinize for hours and hours every little piece and part in the system. It's just not, that's not the purpose of a field inspection in our construction industry and how we do things. And nor is it necessary. So there's a section in the National Electrical Code that is part of the general requirements that all electrical work be done in a neat and workmanlike manner. Now, this is not a sexist comment. This is just a basically saying that that things be done professionally and cleanly. Wires aren't hanging all over the place, which is unsightly, but also, as you might expect, wires all over the place have a bad habit of getting damaged and things like that. So part of the neatness in a project is really making sure that from a safety point of view, equipment is well positioned, it's well secured, the wiring's well secured so that storms and snow and ice and rain will not displace equipment or the wiring, which could easily be a safety hazard. Okay. Continuing on that, what we're looking at is we're looking at the underneath of a solar array. You can see this lovely late 60s, early 70s split level, which ubiquitous architecture, which is better forgotten, but that's beside the point. These people like their home. But let's talk about the solar array on the roof. And when I talk to contractors, I say, hey, I want you guys to build a system that looks like wireless technology. So yeah, there's anchors on the roof that are holding it to the structure. We talked about that in the last couple sessions. But more importantly, the wiring is neatly tucked up underneath. It's well supported and well fastened. If there was any ice ever to flow underneath this, and certainly less likely to catch leaves and debris. If you have wires hanging around and laying on the roof, not only could they be damaged by the rough roof surface, but also they have a bad habit of catching leaves. And then you get large leaf collections up on the roof, which squirrels then, if you're near trees, squirrels think that's the most lovely place to build a home, and then start building homes and nesting in it with chewing on wires. There's all kinds of things. And we have had, we had a fire in Greenbelt, Maryland, in fact, not far from you folks, many years ago. And fortunately, the firefighters were able to put out the fire, but they could have lost the home. And it was because squirrels were living underneath the panels and they'd eaten the wires. So yeah, we're looking to make sure everything's nice and neat underneath those panels. Here's a little Clint Eastwood, good, bad, and ugly slide. The idea that the wiring and cabling be well supported, well secured, rather than just laying on the roof or just in a horrible shape, as you see here. More on neat workmanlike manner, nicely done, looks like it belongs there. And next, issue on the list of our checklist, and this is a little one-page checklist, and you can find it on our website, the website we talked about last time. The model number and quantity of the modules matches what was permitted. So there's a permit that's been pulled, and it tells you what solar panels they're using, maybe what inverters they're using, stuff like that. That's all part of that process. And where they're located on the roof and things like that. And if the contractor got out there and said, you know what, I just don't like this plan at all, I'm just going to change it up. Oh, and the panels I got, I got a different set of panels. I'm going to use the ones that I permitted for another job. I'm going to replace them with these. That creates a real hassle for the field inspector. And then you go up to sites like this, and it's like, what in the world are you thinking? And so there are guidelines out there, but if you notice the guidelines that we talked about the other sessions, the array has to be no greater than 12 inches or 10 inches off the roof. I think we violated that in numerous places here. There has to be away from the edge of the roof by twice the distance underneath the panels. Clearly not the case here. So by following a few of those very simple structural requirements, aesthetically, the system becomes much better. And this array is just not even possible. This particular roof would probably only be able to handle half the solar panels that it currently has on it, and which would make it almost silly to install solar on this particular roof, and you'd be looking at other options like building a carport or something like that and mounting the solar panels on that. So this is a horrible example of what can go wrong. This system did get permitted and approved, but you could also say with some real certainty that if you were to drive around the neighborhood of where this house was, which happened to be in Long Beach, California, by the way, if you drove around that neighborhood, you would find that there are no solar panels on any houses within about a mile of this house. And why is that? Well, the neighbors drove by this house and they saw this and they said, well, if that's what solar's about, I don't want to have anything to do with it. And so when we're trying to get millions of solar roofs in the United States and tens of thousands in Virginia, this is not the way to do it. We have to do it well. We have to do it aesthetically. It's got to look good. And that's why we have these basic structural requirements, which also are aesthetic requirements. They make the system look better as well. Here we see the mounting system. So item 3 is array mounting system and structural connections according to the approved plan. And so every roof has a different flashing method that has to be used. And some of the flashings are fairly simple. The one on the right there is the correct flashing material, but it is improperly installed. So there were many problems with this particular installation. I got probably a dozen photos of what not to do in this project because the contractor, the installer was not trained. The contractor was a decent contractor. The installation crew was untrained, and so they didn't know how to install a roof flashing, and so there it is sitting on top of the shingles rather than feathered into the shingles like it's supposed to be. Roof penetrations flashed and sealed according to the approved plan, obviously not in that case. Array exposed cables are properly secured and supported and routed to prevent physical damage. Okay, so you saw some examples of some well-routed cables that were using the rails that you see there to keep the cables protected and secured and held up off the roof. But here we have a gap in between the array with this is an attic vent for helping cool the attic. And so they did stop the array to go over that, which is good. At least they didn't just remove the attic vent, so that you got to give them kudos for that. But then they just laid the cables on top of the attic vent. And of course, one of the cables was a little bit shorter, so that just took the shortcut and laid across the roof. And so these are things poorly routed, poorly secured. And the code allows us to use for these outdoor rated cables, we can use a piece of conduit and we can sleeve it. So we can support it on each end with those rails, or we could continue the rails across. Either way would be acceptable to hold those cables up off the roof. And the other part about this system is that these cables are fully visible from ground level. So this just looks bad. So aesthetically, it's bad. And again, if something aesthetically looks bad, it's probably bad. And it probably is a safety issue. So this is a safety issue as well as an aesthetic problem. So here is a system that's well secured, where the cables are tied up underneath the array. And you can look underneath the array and you don't see any of these cables. They're easily accessible if somebody needs to repair or do something in this array. And then you'll notice that right across the street from this, since this was well installed and professionally installed, you see another solar array. And then if you went down the street, you'd see 4 or 5 more. And that's what we're looking for. We're looking for repeatability. We're looking for people doing the right thing. And then neighbors look at that and say, I think, you know, and basically it's like, yeah, that doesn't look all that bad. It's not like, I'm not expecting people to go, oh my gosh, I want to put solar on my house to make my house look better. That's not usually going to happen. But what they can say is, let me see your electric bill. And then it's like, oh my goodness, my electric bill is $500 a month. I think I want to do this. And so if it looks good or decent, and the electric bills are getting affected the way they're supposed to be, then we're going to have acceptance of this technology as we have. We've got well over 1 million residential rooftops in the United States and getting close to 2 million as we speak. So conduit correctly installed according to the National Electrical Code and the International Residential Code. The CRC is the California Residential Code. That's just a misprint there. Sorry about that. But International Residential Code has requirements for securing equipment, things like that. And so we want to be consistent with those rules. And so we have some good examples and we have some very bad examples here of how things are put on the roof. Cabling. Okay, firefighter access according to approved plans. Now the firefighter access rules have been changed in the latest, in the 2018 IRC, but I believe Virginia is still on either the 2015 or 2012 IRC, and somebody could maybe help us out with the chat on that. The 2015 IRC currently on most roofs is going to require a 3-foot pathway on the ridge and 3 feet on the sides. That takes up a fair amount of real estate, and the 2018 code has actually relaxed some of those requirements, and I was involved in writing those requirements. So now we only have to have one access to the ridge, and that has to be on the street or driveway side of the house, and at least one more access from the ridge down to either on the same roof face or an adjacent roof face. So that's the new rules, but this is an example of the old rules, and which you folks might still be involved or part of. Here's an example of a house that did catch on fire that had solar on it. The solar array was unaffected. However, the wires for the solar array went to the garage, and the garage burned down. And so, but the firefighters had plenty of room to do their job. They ventilated where you see that plywood on the roof to make sure that the smoke had not made it into the attic of the house, which it very little had been. I think if there was any, it was a very small amount. And so they were able to protect the house, and the garage was lost, and a 62 Impala was burned up in that particular fire. But the point here is that they had plenty of room to do their work. They were unimpeded by the solar. Roof-mounted systems have the required fire classification. And so in most parts of the country, including Virginia, Class C is going to be your minimum requirement. And most every system out there is Class C compliant. So it's really not an issue. In California, Most of our, I'd say 2/3 of our communities require Class A roofing because of the wildfires, which I've personally experienced in the last week. And so in certain areas, fire classifications will be higher, but there may be some communities in and around Washington, D.C. that might have higher fire ratings, and certain types of buildings like assembly buildings or minimum Class B fire ratings, and these are the fire classifications of the roofing systems themselves. The grounding and bonding of the rack and modules according to manufacturer's instructions. And so here we have an example of there may be the wrong grounding hardware and things like that, wire kind of laying around, but most of the systems nowadays use clips that are up in the top left corner. That clip could be part of the top-down clamp, or it could be going underneath the module. Most of these are in top-down clamps these days, and that's part of a grounding and bonding system. And I mentioned this in the last session when we were talking about electrical. UL 2703 is the standard that covers that, and there are many, many systems out there that are UL 2703 approved. However, contractors may not be fully aware of that, and so that makes it easier for everyone involved, including the field inspector, if it's the UL 2703 system, because as you install the system, as you put the pieces together, they have the bonding elements built into them, so you can't not bond the system. Essentially, it gets bonded as part of the installation process, which is really what we're looking for, making it easy for people to do the right thing. That's in all the standards work that I do in this industry, including grounding and bonding, which I was the chair of the committee for that, is how do you make things easy for people to do the right thing? Because if you make it hard for people to do the right thing, then it requires it puts a lot of emphasis on the field inspector, which is unfair for them. If you make it easy, then people comply naturally rather than with this kind of forced approach. Equipment listed and installed according to the approved plans. So we have listing labels, and part of the inspector's job is to see the listing labels and to see that equipment's properly listed and all that. That being said, solar panels, the listing label for every module that I've ever seen in the real world is mounted on the back of the module. And this is kind of a funny joke that I like to tell, but if you can read the labels from above, that means the modules are upside down. Now, I've never run into an installation yet where the modules were upside down. I'm sure it will happen one day, but that's problematic, obviously, to see them because they're on the back side of the modules. And as I said, typically you might have a 5-inch gap. That's pretty tough to see anything. I can't see anything. When I do it, I use my front camera on my phone. I slide it up underneath there. I might use a selfie stick even, and snap a picture of it until I get what I see. I can read the module label. That's the way I might do it personally if I'm required to personally verify. I would also, I encourage field inspectors to accept photos of these things from the installer, unless you think they're shifty and they're not to be trusted. Now, that brings up a whole nother area, which I think we'll talk about at the end, which is virtual inspections, where we actually we rely on photo and video data and information. Sometimes real time. Sometimes these things are real-time inspections with video feeds, and other times it's a video that then is handed off to the inspector and has all the elements that they're looking for. There's a list of things that the inspector wants to see as part of the project, and then the inspector can essentially, from their living room nowadays, do the inspection, see all the elements they would have seen with their eyes, and in a video format, that's a nice way to go because you can essentially do it continuously. Where photos, obviously, you could have a photo library and just BS people. So that video streaming is starting to catch some momentum, especially during COVID, and we'll see where that goes. Number 11, inverters marked utility interactive. Most inverters out today on the listing label will say that they're interactive or utility interactive on them. And that means that they're designed to operate in concert with the utility safely. They've gone through all the listings, all the testing that's required. In order to get that on the label, the standard says you've got to pass a series of tests that the utilities want to see to make sure that this equipment behaves nicely connected to the grid. These inverters are connected right to the utility grid through your house panel. And when you have a utility outage, as we're currently experiencing here in Vacaville, California, then those inverters are sitting offline unless you have battery backup, which I have 4 systems. So that I'm weird, but that's the battery backup systems isolate from the grid and power loads in the house separately. But a normal utility interactive inverter will simply just go and disconnect from the grid when the power is out. And that's for safety, obviously, so you don't re-energize power lines. We have down power lines everywhere. There may be no load on those lines, but if there's no load on the line, you could actually energize those lines. And then when a utility worker goes to pick them up off the ground, to clear things and get ready for the new power lines, that could kill them. And we've had many linemen over the years lost because of mostly because of people hooking up their backup generators to their house and not opening their main circuit breaker to isolate the grid from the house. So those are real issues. A big part of my career, the first 10 years of my career, were spent in working on the utility interconnection rules so that we could do this easily and simply. And for the last 22 years of my career, we've been doing this without hardly any issues, especially at the residential level. It's pretty much a slam dunk. In most communities, I should say. I know that there are exceptions to that. Conductors, cables, and conduit. Sizes and markings according to the approved plan. So here we see a wire that's designed to be or required to be in a conduit laying on a roof. That's not a good thing. We have a specific wire, it's called PV wire, that's specifically rated for outdoor conditions. It's a very tough cable that's used in our PV systems. And it also is rated RHW and sometimes USC2. RHW means that it can be brought inside of a house and things like that. And that PV wire is specially designed for our systems. Doesn't mean that it will be able to handle 20 years of physical abuse. So you still have to properly protect the wiring like you do any wiring in an electrical system. But it is the common product that's used, and it is what the code calls for. Let me do that. All right. Overcurrent devices are the same of the type and size according to the approved plan. Now we're going to skip over this one fairly quickly. If you're working on a system that has fuses in it, it could be in an energy storage system have fuses, but most of your residential, if not all of the residential systems that are being installed today, have no fuses in the DC side whatsoever. So if you have fuses in the DC side, either it's a very old inverter or it's a large system like a commercial rooftop system. And then of course we need to make sure that those fuses have the correct ratings. So you see on the left-hand side the 600 volt AC and DC rating, which would be the correct rating for that particular installation. And on the right, you see a fuse that says 600 volts in big letters, but that's 600 volts AC. And that would be the correct fuse if this was a 480 volt three-phase switch. But if it's not, in small lettering, if it's a DC application, those fuses are only good for 300 volts DC. That's the fine print. You probably can't read it on the side, but that's an example of a fuse that is not rated for 600 volts DC, but it was on a 600-volt DC installation. So fuses can easily be installed improperly or use the wrong fuses, because the DC rated fuses are harder to source. And for companies that are not familiar with that, that's a common mistake in a system that has fuses. That being said, as I said, in recent years, none of the residential projects, other than ones that have energy storage systems, have fuses on the DC side at all. Disconnects according to the approved plan and properly located as required. So here you see on the left-hand side a DC disconnect for this particular inverter, and on the right-hand side you see an AC disconnect for those two inverters. Actually, the DC disconnect is for both inverters as well in this particular case. Now, not all systems have need external disconnects. So we have a lot of the products, I'd say most of the products on the market today, have a DC disconnect integrated into the bottom of the inverter in a wiring center that's kind of a separate wiring center at the bottom of the inverter, where the field wiring from the roof gets terminated and provides disconnection for the DC side so you can service the inverter. The AC side, typically you'll have a circuit breaker in the main panel you see off to the right, or as in many utilities in Virginia, that little switch, AC switch on the right side of the inverters. The inverters, those dark gray or black devices. The little switch on the right side that has the little black handle on it may be required by the utility as an isolation point for their linemen. So that's just a little simple $25 switch. It's a little bit of a pain to install it, but hey, it's just another thing. And so some utilities require it, some don't, and you will probably know which community you're in. But I'd say Virginia probably has quite a few communities that require that. So in this case, the one on the left, the DC disconnect is next to the inverter, which is where it needs to be, but the AC disconnect on this system was not within sight. It was on the outside wall, and that would not be acceptable in the 2014 code. Inverter output circuit is located at the opposite end of the bus from the utility supply. And here we see the sign that's required by the code: do not relocate this overcurrent bus. And that's part of the 2014 code. System markings, labels, and signs according to the approved plan. That's why I had in the electrical plans, there's a notes page that talks about the signs that are required. And photovoltaic systems do require several signs. And so we need to make sure that we cover that. In that little notes page, although there's maybe 3 or 4 separate signs on that, there's a total of about 8 sign requirements that are covered by those signs, maybe 10. And so we've kind of morphed or merged them into a shorter number of signs, so it's easier to apply the signs and install them. But here's an example of properly designed signs and all that. Okay, system markings, labels according to the approved plan. This is a fun little picture. In California, we have a lot of stucco, maybe not so much in Virginia. We have a lot of colonial in Virginia. Stucco was not a big part of the colonial architecture. More of a Spanish thing, but here we have stucco that covered over all the signs. At least they masked the meters, which are 3 in this case, which is kind of interesting, and the display on the inverter. But they stuccoed over all the signs that were installed here because the owner didn't like the looks of all those red signs. They're kind of ugly, and I agree with them. They're ugly, but it's what the code required. It's kind of a humorous picture. I love that shot. Okay, connection of the PV system to the grounding electrode system according to the approved plan. Normally, what we're doing with our normal designs, and if you see that with the electrical stuff we talked about last time, It's just simply, we're not actually driving new ground rods unless the existing ground rod system for the house is inadequate. Maybe it's a water pipe ground, older installation or something like that. So a lot of communities will require ground rods to be added, things like that. So that's really what we're talking about here. And the equipment grounding conductor, which is coming off the solar panels, which is run with the wiring coming off the roof, that equipment grounding conductor is all that's needed in order to make that connection to the equipment. And then we're just making sure that the service is properly grounded. And if we do that, we've done everything we can possibly do to make sure that that system is safe from a grounding point of view. Now, in Virginia, it's not uncommon to have a lot of lightning storms and things like that. So lightning protection may not be a bad idea. It's not a requirement of the National Electrical Code. It is a personal preference thing. However, if a house or a building has a lightning protection system, then it is required that the PV system, if it is within 6 feet of that equipment, has to be bonded to the lightning protection system. And so that is something to be aware of from a lightning point of view. It's pretty rare, I would say, but the very first system I installed in 1988 was in an area that was very lightning prone in Raleigh, North Carolina. And the facility I was installing on it had lightning damage several times to the electronic equipment. And so we put in a lightning protection system specifically to protect not just the house, but the PV system. And that was a very effective thing. And the lightning problems that had been plaguing that house for years went away. So lightning protection is a real thing. Ben Franklin kind of invented a lot of that stuff a long time ago. He was a great dude. And they perfected that science quite nicely. But anyway, that's just something to be aware of on the grounding side of things. Access and working space for operation and maintenance of PV equipment. And so it is very common. Now here you see some kind of bamboo or something being grown right in front of an electrical panel. I don't know that you're gonna have a lot of bamboo in Virginia, but you could have all kinds of ferns and shrubs and bushes and trees. People do that a lot because they don't like the looks of those unsightly meters and inverters and stuff like that. And that just creates a real problem, not only for the meter reader, if you have, manual meter reading, but also to physically get the equipment. And you hear on the left side, you see an old school battery based system. And in order to work on the electrical equipment at the end there around that blue box, you actually had to physically stand in the battery box to work on the equipment. The main thing there, I guess, is don't sit down. Well, that's not acceptable according to the National Electrical Code. That's not the access that is required to electrical equipment. And so like lots of violations there and safety concerns. Rapid shutdown is a new thing that came into the 2014 code. It's a fairly simple requirement in the 2014 code and very kind of open-ended. And basically says PV system equipped with rapid shutdown. That's the main sign that's required. Now the sign that you see in the bottom right is the sign that was improved or we added to that sign for the 2017 code. So it's not required. The one in the bottom right is not required, but it certainly can be used, and those signs are readily available from every sign company that makes signs for PV systems. The top of that sign is what is required, and the rules for it are fairly simple. To shut down the wiring coming off of the solar panels, once the wires leave the array area where the solar panels are, then the wiring needs to be shut down if it's more than 10 feet from the solar panels. And so that's the 2014 requirements. The 2017 code requirements and onward are more stringent than that and require shutdown actually typically to the panel level and stuff like that. But until you're required to enforce that, just simply having some kind of a shut off that within 10 feet of the array. Typically, it's an automatic shutoff. There are many products out in the market to do that and would require a sign that says solar system equipped with rapid shutdown. So with that, I am going to, I ended right on time, quarter till, open it up for questions and open it up for Nick to talk to us about any questions that might come up.
Yep, and I'm going to start off with one that came through a bit earlier, but I think it's a good time to address now. Starting to see a lot more battery backup installs with PV. Can you elaborate on how NEC 702.4 is addressed?
Oh, now we got somebody quoting the code like the Bible. Well, look at this. I bring up the code and where am I? I'm at 702.4. Well, I think I must have been connected with this person or something. Well, my opinion about 702.4, I probably have to leave alone, talking about capacity, because with a backup system that's optional, my personal opinion is that the National Electrical Code completely lost their way with this section of the code, and we're trying to resolve that in the 2023 code. That being said, it basically says if you got a manual transfer switch, you can manually turn stuff off and you're just fine if you have a backup system. And if you have an automatic transfer, then you either have to size the loads on that system for the capacity of the inverter in this case, if we're talking about our battery backup system with an inverter. So the inverter has to be capable of operating that equipment if it goes into backup mode, or you have to have load management that turns that off. Now, the way it's done mostly, without going into a lot of detail, is that we only select a few circuits, maybe 3 or 4 circuits out of our main panel. We actually physically remove those circuits from the main panel, and we put them in a sub panel that is run directly by the backup system that's running off the battery. So that's a full load of those circuits, okay? And so we might have an output of 30 amps at 240 volts, and there's a lot of houses that can run just fine on 30 amps and 240 volts. But the circuits that we select are within the realm of that inverter's capabilities in that sub panel, and that would meet the requirements for full load. And then if we didn't have that, if we were trying to transfer, let's say, the entire house over to the backup system, and that backup system only had a 30 amp, 240 volt output to it, then clearly a 200 amp panel could not be run on that, and we'd have some kind of load management. And there's many companies now coming out with load management products that either have relays or breakers that trip and things like that automatically in an outage, that basically pair the loads down to the capabilities of the inverter, or could be a backup generator, which is how 702 was set up. So nice question, very relevant to today.
Great, thanks, Bill. Another question about shutdown. Is it impractical to shut down conductors within an array?
Is it impractical? Well, I think that all depends on your view of the world, but there are many products out there that can do that. That being said, the 2014 code does not require us to shut down circuits inside the array, only circuits outside the array. The 2017 code and 2020 code require us to go to an improved safety level inside the array, which, as of today, the main products that are able to meet that requirement are what we call module level electronics. Some examples of module level electronics would be microinverters, where you have an inverter on every panel. So we just turn the microinverter off, and so that turns the individual panels off, and you only have the wiring that goes from the panel to the microinverter left as voltage on the roof, which is acceptable according to 2017 and 2020 code. But we've got a whole new realm of DC converters DC optimizers are called from SolarEdge. That's a company that coined that term, DC optimizer. And then I've been testing some products where it's just a simple switch, and each module plugs into a switch, and that switch is remotely operated by the rapid shutdown switch to turn the modules off, essentially to their wiring. So the wires coming out of the module are still energized at maybe 50 or 60 volts, and the circuit is de-energized going to the inverter. But as long as the circuit, the wiring within the array is below 80 volts, then it meets the requirement of the 2017 and 2020 code. And again, those would not be required in the 2014.
All right, thank you. You'd kind of mentioned this earlier, but just wanted to see if you had additional thoughts on virtual inspections. Do you have any kind of tips or best practices to adhere to there?
Yeah, well, COVID-19 has clearly changed everything, and communities that were maybe hesitant to consider something like a virtual inspection or a remote inspection where you weren't physically on the property. There's a lot of communities that said, absolutely not. That's not what we do. We have our inspectors and we run them ragged all day long, running from place to place to place, and we think that's the way to do it. And it's like, okay. But COVID changed everything. And so now there are a lot of communities around the country that have realized that allowing some level of virtual inspection is necessary and appropriate. Now, there are going to be things that you just can't use virtual inspections for. There's certain types of testing and things like that. Also, what we're seeing is that there are a lot of third-party inspection companies doing the physical inspections for communities much more than they used to. That service has been around for years and years and years, but not every community is taking advantage of it. But we're seeing lots and lots of communities taking advantage of that. They're not putting their people at risk, and it might even turn out to be cheaper in many ways to actually hire a third party, and that third party is managing the risk of exposure and things like that to COVID, and they have things in place. And that's also, at least in the near term, is meeting a lot of the needs of inspections that I see out there today, where communities just haven't come up with an effective method of protecting their field inspectors, and the field inspectors are not comfortable with doing that yet. And so there's a lot of reasons why we're seeing virtual inspection. As I mentioned before, I think where we're going to go with this virtual inspection process, there's actually a new standard, and don't make me quote it because you can Google it yourself and you'll be right. It starts with a 9, UL 967 or something like that. It's a new standard for virtual inspections or remote inspections, and it goes into how you would go about doing that and setting that up and things like that. So there's a lot of activity right now trying to get that figured out, and what are the challenges with that whole process. But I'm willing to believe that the most reliable way to do it, if it's possible, is actually a video style approach, where you can start with the address of the house and work your way through the process with an actual video camera phone video of the installation, which is every bit as good as seeing this stuff in person if you get the right things. That's the key, is you got to get the right information, and then you've got to upload this video, which could be several gigabytes of data, or at least lots of megabytes, shall we say. And so how do you upload that process? Those are all kinds of the fun logistical issues with that. But with a video, you're really confident that you're at the site, things like that. Whereas photos, which are fine as long as everybody's telling the truth. The problem with photos is that I can take photos of 10 different locations and use them for 100 different inspections, and that doesn't meet that kind of defeats the purpose of field inspection. So communities are going to be using a combination of photos and third-party folks. So if you have a third party, accepting those photos is not a big deal because they don't have any reason to lie about the installation. But if it's done by the contractor, then a video inspection is probably going to be where people are moving to in the future. And it's an exciting time. I mean, with all the pain and suffering of COVID, it is advancing technology in a way that and bringing people, I like to call it bringing people into the 20th century, which is my joke because obviously we're in the 21st century. But there's a lot of things we did in the 20th century that a lot of communities haven't gotten to yet. So hopefully we can get everybody on the same page and improve systems, provide for the safety that's necessary, and lower costs all at the same time, which is a really big ask, but I think it's absolutely possible. Any other questions?
As of now, I don't see any. So I'll leave it to you with any final thoughts before closing us out.
Great. Well, thanks everybody for participating. And as I tell the thousands of inspectors that I've taught over the years, the field inspector is a well-informed field inspector is the friend of the solar industry because we need to have things done properly. We need to have things done safely. And if unsafe practices are allowed to persist, it creates a whole problem for our solar industry. Not only is the possibility of a safety hazard and somebody being injured happening, but it also it creates a real problem for good installers that are doing the right thing. So if an installer is doing all the right things and they're dotting their I's, they're crossing their T's, they're installing things well, taking the time to do it right, and then an inspector or an installer who doesn't care comes along and is doing things improperly and cutting corners and things like that, then they fundamentally are creating an economic problem for the good company. The good company is going to go out of business. The bad company is going to stay in business for a while until they've done their damage and left town. And then the homeowner and the customer are going to be left out in the cold because the equipment wasn't installed properly, not working properly, not set up properly, and things like that. So for those of you who are on the call that are direct field inspectors or supervising inspectors, be encouraged. I enjoy working with inspectors. I encourage you to contact me directly if you have inspection questions. I'm happy to answer those questions. That's part of the technical assistance project with SolSmart. And so Nick can get my information available to you, and you certainly can contact Nick and Toya directly, and I'm happy to help. And thanks everybody for taking your time today, and enjoyed the opportunity to speak with you. Wish we could have done it in person.
Great. Thank you very much, Bill. And a big thanks to you for being able to join us for this 3-part series. Very challenging situation for you, so we do greatly appreciate that. I will share the slides, or we will share the slides. The email may come from Carrie or Elizabeth. We will share the slides with everybody for this field inspection. We'll probably include the ones for simplified solar permitting as well, the recordings. And as I said earlier, we'll look to host those recordings either on SolSmart or DMME's YouTube page. As Bill said, please share the word with your colleagues that may have missed these trainings, others in AHJs next to yours, to review them, just so you stay in the know in terms of the best practices and the latest developments. And with that, we will close out the training series. Hope you all enjoyed it, and have a great day.